So a lot of people have been asking what the point of that last demo was. And it showed the system creating all of these different auto-generated files and then using them. It was really interesting. And I think quite a few people caught on to what was happening, but quite a few people also wondered why this exists and sort of where that's going and what's actually happening here. So this is going to be a bit of an exploration into what I think is genuinely just magic. And the fact that, that we can do this is genuinely insane. But before we do that, I'm actually just I've created a little demo folder here with just one file inside of it. And that is all the data that our entire system, beginning to end, has got to go on, right? So there's no custom prompts in here that relate to the content of that data or maritime or anything in there. The code is entirely general purpose and can work, if it can work on this, honestly, it can work on quite a large number of data sets. So what I'm going to do is I'm just going to point us at that file. Now I've also pre-generated some data. So we'll look at those while this is doing its thing. So I'm just going to run this and it's just going to go off. And now it's just going to start generating a bunch of stuff. So you can already see this a JSON file in there. And that's pulling in sort of examples of that data, but that's all it has. And it's trying to pull out structure from that data. And we'll see shortly why that's useful. First, let's look at the data. Now, this is, as much as it gets, this is really massive data, right? So if I just move that over there and I just sort of close this, you can see that data a lot more flat. So this is a lot of different sheets. It's an Excel sheet. It's a good representation of the kind of relational data that we're working with. So this is a massive file with just sort of, in some cases, hundreds of columns of primary keys, profit and loss, fixtures, and they all relate to each other. And this is kind of really complex data that's been transformed into flat. And quite a bunch of organizations have their data sitting in this format. Now, I'm not saying that there's organizations that are running on an Excel sheet. I'm not saying that there aren't. But a lot of data tends to be in this format where some amount of cleanings happened, but oftentimes the context that you've got to go on is effectively this. And the process of running an ETL pipeline or creating one oftentimes is looking through this data, understanding the relationships between them, understanding what each column even means, what kind of types fit into that data, and then working with that. So in this case, it's starting to create a whole bunch of these different files. And if I just pull this in here, it's starting to create a whole bunch of these different files, and we'll look at what any of them individually mean by looking at sort of a completed version. So this is the same file. This is just now completed. And the first thing it's going to do is it's going to start. So everything it does is just going to go into this one massive JSON, and that's a way of saving progress. Just a very quick and dirty way of saving progress that I've often used. But the first thing it does is that it goes in to create a type spec. And TypeScript has been incredibly useful here because it's very terse and it's very expressive at the same time. So what that means is when you've got data that you want to describe and you want to pull out some amount of structure, it represents a way that you can then manipulate that structure by looking for supersets and subsets. There's a lot of deterministic transformations that you can make to that data. So the first thing it's doing, and this is all running, this is a large number of prompts running in parallel for speed. That's why you're seeing the output sort of garble. And this, for me, it's a progress report, right? But this has now pulled out quite a bit, including comments of information about that data, just from a single row in some cases, or multiple rows in some cases, as much as is needed to. So incrementally optimized for what the format of that data would be. So now it's pulled out that type spec. The next case, and it's not waiting for that entire process to be done. It's going to go ahead and create a DDL for us. In this case, I'm using SQLite, but you can use different flavors of SQL. And now it's created that DDL, which describes how that data would be structured. And here we've got our first structured DDL come through. The other ones are null because those are waiting to get filled in. Structured DDL is just an internal intermediate representation that we use to effectively describe that data in more depth, describe that schema in more depth, in ways that we can then better represent it to an LLM when we need it to query or to other formats. So this is, kind of a superset of a lot of different ones. If you don't have an ORM, you end up building one. This is, I think, as close as we get to an ORM in our situation. So we've got a structured DDL here, and that is, not almost entirely auto-generated. That's about, 4984 rows. Now, if I run effectively the pipeline on a completed set, all I've got to do here is just go in here and then change it back to standard one. Actually, no, that's not in the demo folder. And now if we just run it, you'll see it's done a whole bunch of stuff, and almost very quickly, it's ready for a query. Before we run that query, I'll explain to you what's actually happening. So it's loading the sheets in, it's generating these mappings. That's what's happening below that you can see. And then it's intelligently matching that generated data. It's looking for errors, looking for where the LLM has made mistakes, asking for fixes. All of that reflection is also happening simultaneously in the prompts that you see below. And then it's matching all of that data together to do a final check of matching schema to the data to make it ready for import, because we're going to use a deterministic SQL database. In this case, SQLite's the backend. And oftentimes working with that significantly smaller subset of SQL can be really, really advantageous, because the only place you can go is up in terms of adding functionality and complexity. If you get used to all the pragmas and all the additional vocab of SQL that's present outside, it can be hard to stop. So in this case, it's SQLite. In this case, we're then going to be matching up all of those. We're skipping some because the LLM deemed that they weren't so important. We're matching all of these. This is just here so you can do a manual check. If this was a UI, you would manually verify. The primary intent here is for us on anything we build is to build in as much observability, not just from our perspective, but from the user's perspective as possible. And there's two benefits to that. One is obviously we want the human in the loop as tightly as possible when it comes to high intelligence tasks. And B, users tend to be more accommodating of results and more confident about results if they know the thought process behind it, and they can better understand, or they had a hand, or they feel like they had a hand in the eventual output as opposed to getting to an output. On top of that, you also get the ancillary benefit of latency. Users get to see something very quickly. I know I prefer that almost immediately, and they get to be a part of that journey. They can even interrupt, as opposed to 5 minutes to do something incredibly smart that you might actually have to trust. So what happens next? What happens next is once that mapping is done, there's going to be a quick slice being shown to you, and that's an easy way for you to verify that everything works. This is where the rubber really meets the road, because the data, which has been untransformed, now gets transformed according to the structured DDL and the additional information that we've generated and all of the reflection and fixing that has happened. And then all of that comes through here, and we just do a quick check. We come down here. That's the DDL that was generated for the database. And based on that, we've now inserted those rows. So this is just a small slice of that information. We've done a quick test. But the really cool thing happens at the very end. Now I can easily say, how much money did I make in profit over all time? And now that is the DDL. That is where the structured DDL comes in handy. This is dynamically generated data in a lot of ways being passed back to the LLM and intelligently reconfigured for incredibly large data sets, because remember, this DDL by itself is thousands and thousands of tokens. But very, very quickly, we've now got to a query and an answer with dynamic typing on the output as well, because we typed the inputs well and then represented those inputs to the LLM. So we're trying to preserve as much information as possible, structured and unstructured, that when we get outputs on the other side, those are also dynamically typed, right? And we've also got an engine that can pull that out. The way that works is visual search, and this is going to be an upgrade that's coming in. I say upgrade, but a lot of it is also then just breaking it apart. Is Wishful Base Engine is going to be the next part of Wishful Search's upgrade, where all the functionality inside of Wishful Search is now going to be broken out into base engines and adapters that you can mix and match. If you want to bring in Excel and do automated typing, you can do that now. If you want to bring in, let's say, Postgres and then just connect up your Postgres directly with security guarantees, you can do that. All of that to provide live queries and also automated reflection, and then agentic behavior, which Visual Search has today, but it's something we're improving over time, which is where the LLM or the model can then look at its own output and recursively improve the output. That can be really, really helpful when you've got multiple large data sets, and the answer you're looking for comes from combining those multiple data sets. So I'm really excited about this. And I think this is genuinely, it would have changed my life if it existed a couple of years ago, because a lot of our time in shipping especially was building these ETL pipelines, and we've spent weeks, if not collective months, there just understanding data and just writing massive amounts of code to extract and load that data into a common format just so you could query it. And by the time you get to a place where you can query it through anything more common, like even SQL, you've already won. From that point on, there's a lot you can build on top. And I see a lot of products and a lot of things being built on top of that SQL But the truth of the matter is, most of the world's data needs quite a bit of work, AI or human, to get to that point. And I think that's something that we were always excited about automating or building, because it just takes up so much dev time or so much time from our customers, that I think this is the first glimpse that this can be automated. I'm not saying that this is perfect. I'm not saying that this doesn't need a lot of improvements, but this works today and I didn't have to fix anything. So if it works today, with models getting smarter, with more work going through version 0.0.1 of beta, I'm now confident that this is going to be done in the next year, if not the next 2 years, that this is now going to be a solved problem. And that has huge implications for all the data that's out there in the world, inside of organizations, inside of governments, inside of maybe even ourselves. Uh, that the data that we generate, we have been unable to use them with the last 20 years of expertise in fast, quick querying and indexing, simply because we have not been able to automate the process of bridging that gap between data that contains information about its own schema, in some ways like self-documenting code. Data, if read right with the right context, has most of the information you need to infer schema. And after all, that's the work that I'm doing when I build an ETL pipeline, to perfectly typed, perfectly executing code, over here in deterministic land. So this is what we're really, really excited about. Just the fact that this can happen is incredibly exciting.